Okay, the next problem for vectors by component addition, or vector addition by components rather, we have a skier that is accelerating at a uniform rate of 3.8 meters per second squared down a hill which makes an angle with the ground of 30 degrees. What is the vertical component of her acceleration? So we're only looking for the vertical component in this particular problem. The information that we're given is we have an acceleration of 3.8 meters per second squared down a hill which makes an angle with the ground, so that's going to be important, angle with the ground of 30 degrees. Okay, so if we were to graph that out, we want to have a vector that is pointing at the ground at a rate of 3.8 meters per second squared, which then makes an angle with the ground. Okay, so here's our ground down here at the bottom of the graph. Makes an angle with the ground of 30 degrees. Okay, so what we are trying to figure out is the vertical component of the acceleration. So we want to know what is the acceleration in the vertical direction. Now, we have enough information to do this. We're going to need to use a trig function just like we've done before. So if we look at our three trig functions, so we've got the sine of theta is equal to the opposite over the hypotenuse. Cosine of theta equals adjacent over hypotenuse, and tangent of theta is equal to opposite over adjacent. So let's take a look at what we have. We know our angle theta is 30 degrees. We know that our hypotenuse is the 3.8 meters per second squared. And the component that we're looking for, so this vertical acceleration, so acceleration sub v, so vertical acceleration, is opposite of angle theta. So we know that our opposite side is the side that we're looking for, the acceleration in the vertical direction. So if we take a look at what we know and what we're looking for O, we know h, and we know theta, then that means that the one that we're going to use is our sine function, because we're looking for O, we know h, and we know theta. Theta is 30 degrees. Our h is 3.8 meters per second squared. And O is the thing that we're looking for. Since we don't know the adjacent side and we don't care about the adjacent side for this particular problem, because our adjacent side would give us our horizontal component down here, we don't care about using cosine. And since we don't know either the opposite or the adjacent side, we really can't use tangent. So the trig function that we're going to use is the sine of theta is equal to the opposite over the hypotenuse. So if we go ahead and set that up, sine of 30 degrees is equal to our opposite side, which is what we're looking for, the acceleration in the vertical direction, over our hypotenuse, our known quantity of 3.8 meters per second squared. So if we multiply both sides by 3.8, we can rearrange this and get the variable that we're looking for, acceleration in the vertical direction, by itself. So 3.8 times sine of 30 degrees is equal to our vertical acceleration. Okay? So the next step would be to pull out the calculator and go ahead and calculate the sine of 30 degrees. Those of you that know special triangles probably already have this memorized, but the sine of 30 degrees is simply 0.5. So if we take that and then multiply it by 3.8, that will give us our vertical acceleration, which means that our vertical acceleration is 3.8 times 0.5, which is 1.9 meters per second squared. So our vertical acceleration is 1.9 meters per second squared.